Hello, everybody, and welcome to another exciting episode of JavaScript Jabber. Today, I'm all on my lonesome, Dan Shappir, coming to you from Tel Aviv in Israel, and I'll be interviewing Aiden Bai. Hi, Aiden.
Hi, how are you?
I'm doing well overall. How about yourself?
Doing well. It's a not so hot, not too cold day in San Francisco, so
Oh,
always a
that's
good day.
lovely. So kind of same over here in Tel Aviv. So at least we're sharing good weather. And we are here today to talk about React performance. But before we start, Aiden, maybe you can tell us a little bit about yourself and your very lengthy career in tech.
Yeah, I got started coding in middle school, but like you might know me for Million JS. It's like I tried to make a compiler for React, and then more recently ReactScan, which is all like the purple flashing boxes on all these popular websites. You see it on Twitter. Um, I've mainly focused on performance most of my life because I think it's an interesting problem. Not many people focus on it, and it's also very hard. Yeah.
Tell me about it. It's been one of my main focuses for the last couple of years. For those of you who don't know, I also happen to be an invited expert on the W3C Web Performance Working Group. Maybe you should join us there as well. We talk about things not so much related to React, more about the relevant web standards, things like Core Web Vitals and stuff like that, and the APIs in the browser that can be used to retrieve them, to measure them, etc. I know that's not our topic, but I do want to talk a little bit about Million JS because it seems so interesting. So, as I recall, it's kind of a drop-in replacement for the mechanism in React that transforms the virtual DOM into the actual DOM. Is that a more or less correct description?
Yeah, that's correct. Like basically how React works under the hood is it takes like two versions of the view. So like the old version and the new version, and then it reconciles it. Like it figures out the differences between those, and then it applies it to the actual DOM. But like this is like an O of N operation or some large O, big O notation that's over O of one. Um, and the problem with that is if when the the versions get really big, like the trees get really big, you're doing a lot of computation. So I was like, okay, wouldn't it be cool if you could precompile this? Like, okay, based on the JSX you provide, there's like obvious points where it actually changes. Like when you have those JSX container expressions, like the when you pass like some data in. And so I precompiled that and then found like the specific code paths that matter to make the DOM changes. So every time you render a component, instead of doing that whole reconciliation process, it just changes the DOM like pinpoint processes basically.
Kind of implementing fine-grained reactivity in a sense over on top of React, I guess,
Yeah,
right?
like the benefits of fine grained reactivity, but without using fine grained reactivity.
Yeah, I think you kind of mentioned several things that are kind of important in the context of React performance as you were describing this. I think that first and foremost is this whole thing about virtual DOM and the reconciliation. We actually had a couple of chapters in JavaScript Jabber talking about the virtual DOM, what it is, why it exists, etc. But I still think it might be worthwhile to talk a little bit about what it is because it's so central to everything we'll be talking about today. So, can you tell us a little bit about the virtual DOM from your perspective?
Yeah, virtual DOM is basically it's kind of an overloaded term. It's basically taking two like versions of the UI and figuring out the differences between them, and then actually changing the UI. React doesn't actually hold the DOM tree inside of itself. I mean, it kind of does, but like when it does, when it figures out what to change, it doesn't actually store the DOM nodes as the whole tree and then diff the DOM nodes. It diffs like a virtual version of it. Um, this can lead to some problems. So for example, like for Facebook, it might be somewhat okay. Like when we were switching pages, but like if you are creating like a stock trading app, like a stock trading dashboard, where like there needs to be like updates every several, like some amount of milliseconds, or you're making like significant DOM mutations every single second, or if your website targets like very low end devices, then that sort of mechanism can lead to some performance problems.
I think the key aspect here is that React took what I consider to be kind of an idealized approach to UI generation, which is let's, in an ideal world, I would say, the React approach is let's take the entire application state and apply like a function to it, a pure function even, that generates the UI that the user sees. And that every change in the state would ideally again regenerate the entire UI. So, you check or uncheck a small checkbox in the UI, and theoretically, the entire user interface of the application gets re-rendered, because then you don't need to think about state changes in the user interface. It's just everything again and again from scratch. But the problem with this approach is that a naive implementation would obviously be just way too slow. It's kind of taking, by the way, the approach that we had in the old days of the multi-page applications and kind of applying it to the client side rendering mechanism that we have in JavaScript code that updates the DOM. In that, in the old days, you would go to the backend and then you would get the entire page back each and every time. So it's kind of like doing that, but again, doing everything on the client side and doing it for every state logical change. And the virtual DOM was like the first thing that they implemented in order to make it viable from the perspective of performance. That is, the virtual DOM, by the way, it's a fancy term, but really all it means is JavaScript objects. Really, that's all the virtual DOM is. So instead of having actual DOM elements, which are rather heavy because of all the functionality that they encapsulate, you just use JavaScript objects, simple JavaScript objects as stand-ins. And like you said, when the state changes and a new virtual DOM is created, React then takes the new virtual DOM, the old virtual DOM, does a comparison, finds the differences, and then calculates the minimal amount of actual DOM changes to transition from the first state to the second state, and that's the reconciliation process. And for a long time, it was thought that that approach was good enough in terms of performance. But like you said, when user interfaces started becoming more complicated or more complex, and as we needed to support lower end devices, like more mobile devices, for example. And as we needed more frequent updates, even this type of optimization started to break down because doing all this reconciliation work still has overhead. And this is when Million JS, I guess, came in to start to try to reduce that by, like you said, being able to be smart about pinpointing the exact locations of the differences and not having to do the entire comparison of the entire virtual DOM tree, right?
Yeah, exactly. I view like virtual DOM as more of, in historical context, like it's more of getting things correct. Like before, people use like Backbone or they roll their own JavaScript libraries, and this would literally result in like there were literally so many framework like bugs in these frameworks. Virtual DOM is like a very exhaustive approach to the problem, but it's more likely to get things correct than not.
Yeah, because when you're essentially building the entire UI from scratch from the current state, you don't have to worry about an incorrect UI transition or
Yeah.
state transition messing up your display. I think uh, Facebook they had this story about one of the motivations for creating React in the first place is that they had a counter in their user interface about the number of messages that you had pending or something like that. And any change to that mechanism was always buggy
Yep.
because they always had to somehow sync with everything else that was changing on the page, and because so many things were changing more or less concurrently in the UI, all of them asynchronous to each other. They would always get into edge cases and edge situations, and being able to just re-render the entire UI from scratch virtually solved that problem very neatly. But again, so we had a couple of performance issues. One performance issue is the one that you addressed with Million JS, which is the fact that even that sophisticated reconciliation could be too slow, especially if the virtual DOM was really large, especially if the device was low end, and especially if you did it very frequently. The other problem, I think, is that even building the virtual DOM, which is mostly just running your code that generates the JSX from the state, can be heavy and performance intensive if done too often,
Yep.
or if it's just too complicated. And I think that this is where ReactScan comes in, because that's your new project, the one that we're going to talk about, because it strives to, if I understand correctly, minimize the amount of redundant help you to minimize the amount of redundant re-renders that you perform. Correct?
Yeah, exactly. I can give a brief introduction. Basically, ReactScan is a tool that helps you find like re-rendering performance problems in your React app. Today, you can just drop it in your app as a script tag, and it basically highlights the components that render and potentially slow down your app. Um, I spent like maybe 3 years optimizing websites, everything from like WebRTC, like virtual camera websites, to e-commerce websites, to like static sites. And when I try to debug these performance problems on these sites, it's really hard. Like it's either like I do console.time and time end, or I use Lighthouse scores, which is like at skill level 0, to profiling tools and Chrome Dev Tools, React Dev Tools at like skill level 100. And so there's like nothing in between those two types of tools. Um, and this made me really frustrated, right? I spent so long just trying to understand how these level 100 tools work, that I realized that most people don't have the time or ability to figure it out.
Or
Uh,
inclination.
exactly. So ReactScan helps bridge the gap. Today we do renders, but soon we'll support more stuff in that, like INP, CLS, LCP, which are like the Lighthouse, Google Lighthouse scores, as well as stuff like long tasks, FPS, all of this like metrics and stuff that are decently like not like decently hard, like decently not easy to measure correctly and interpret, basically.
So you threw out a bunch of metrics,
Yeah.
as I mentioned, metrics are near and dear to my heart. They're part of what I do on the W3C Web Performance Working Group,
Mhm.
which I'm an invited expert on. Um, I think the three main ones referred to as, unsurprisingly, as core web vitals, because they are the core ones. We talked about them on this show on several occasions. I think we even had specific episodes dedicated to them, but still, it might be worthwhile to mention what they are and what they measure. Do you want to do that, or should I?
I can explain like 10 seconds. Like INP is basically interacting in a page and getting the result back visually. LCP is basically the largest like contentful, basically any element with text or image, some big text in it, and it's the like what however time it loads. And then CLS is basically how much your page layout shifts. You want your INP to be as low as possible. You want your LCP to be as low as possible, and CLS to be low as well.
Yeah, exactly. And it's interesting because they are not trivial in the context of React, especially.
Yeah.
And it's interesting because different facets of React address these different metrics. So, for example, if we're talking about the largest contentful paint, which, like you said, is the amount of time from when the page starts loading until the largest piece of content is actually rendered on the browser screen, If we think about what React does to try to optimize it, so initially React, for those who may not recall, was just client-side rendered, and that kind of guarantees slow LCP by definition, because nothing is shown until all the JavaScript is downloaded, including React, and then the client-side JavaScripts need to do the AJAX calls to get the data, and then render the UI based on the data and the code, and only then do you actually see anything on the screen. So that's when React introduced server-side rendering and or SSR and static site generation or SSG with meta frameworks like Next.js or Remix. Um, so it's, by the way, it's interesting in this context that still many organizations that I encounter don't really care that much about LCP in the context of React applications, because a lot of the web applications that are built using React are things like dashboard or internal enterprise applications. And there, their approach is that it's loaded once and then used all day long. And therefore, the loading time is less important. I actually think that in many cases this is a misguided view, because, for example, let's say you're commuting to work on a train, you want
Yeah.
to use that time, you're connecting via VPN into your internal network, you're loading your internal application, and it takes your entire train ride to actually load, which isn't fun. But be that as it may, so that's LCP. There's the INP, which you mentioned, which is how responsive the page is to interactions, how long it takes the page from when you actually click on a button to actually render the result of clicking on that button. And again, React can be really problematic there, because if it's doing very lengthy rendering operations or re-rendering operations, and you click in the middle of one of these operations, then it won't actually respond or do anything until all that JavaScript finishes running.
Mhm.
And CLS, I think, is the one that is least directly related to React itself, because it has more to do, I think, with how you style your CSS, stuff
Yeah.
like that. I would say, though, that for people who are using, what's it called, React Suspense, they need to watch out for CLS, because if their loading code doesn't match the size of the actual finally rendered component, then things will shift after the loader is done. So you do need to watch out for that if you're using suspense in the context of React, I think. Would you agree with that?
Yeah. Also for images, right?
Yeah, but images are that's a universal issue. That's not React
Yeah. Makes
specific.
sense. Mhm.
Yeah. So Million JS kind of addressed, I guess, both LCP, because you were running the rendering code faster.
Mhm.
Um, and also it kind of addressed INP, because it blocks the rendering time for a shorter period of time.
Yeah.
What I understand that you're addressing with ReactScan is mostly about figuring out how to do less rendering, and also generally make the rendering itself faster, which again would primarily benefit INP, I guess.
Um, I see it as like rendering is always somehow related to some performance problem on the page if you use a React site. Like, well, I'll give a couple examples. Like, for example, with CLS, right? Um, it could be a styling issue, but as a user, I want to know like where that uh specific like layout shift is occurring. With INP, I want to click a button and there's like maybe a bunch of renders. I don't know why it's slow. Rendering is somehow related to that. Even LCP, as you said, right? Like if there's a lot of rendering on the page that doesn't need to render, like maybe below the fold or outside the viewport, then it's not good, right? Even like other performance issues, like when FPS drops, or like um, uh, I'm trying to think of other examples, but like whenever the page feels sluggish, it's always rendering is always somehow related to the problem.
So FPS, can you elaborate on what that is?
FPS is frames per second. Basically, this is important for movement or animation tasks. So, like when you scroll the page, or something is animating like rainbow gradient for some reason, that FPS is important. You want to usually keep it over 60 FPS. Is the standard.
And again, JavaScript gets in the way because the main thread, well, the browser is kind of not exactly, but mostly single threaded. So
Yeah,
whenever you're running JavaScript, it kind of blocks everything. And
yeah,
if you're blocking everything too much, then you get jank or jitter because you're not able, like you said, to hit that 60 FPS. Um, I totally agree with what you said about identifying things that render needlessly. My own experience is that a lot of React teams don't even ever get there.
yeah,
Basically, when they see that something that the UI renders correctly, that's good enough for them, and they don't care about the fact that it's rendering correctly over and over and over again, effectively doing a lot of work at the virtual DOM level without actually ever updating the actual DOM, because the reconciliation basically notices that they're just recreating the exact same virtual DOM over and over again.
yeah.
But even that, even though it's cheaper than updating the DOM, still, you know, accumulates if you're constantly doing that. You're literally just running an infinite loop of JavaScript that's doing nothing. Is that been also your experience, that it happens in a lot of organizations and a lot of websites?
Yeah, that's definitely one of the problems. It's also, I don't think it's necessarily engineers' fault, right? It's really hard to care about these things because they're not visible. Just like if the page UI is not correct, it's very visible. You have to fix it. If there's an error, you have to fix it, right? It's not like you can avoid these things. The performance you can pretty easily avoid because most developers use like a really high-end MacBook or high-end PC, where you can like any performance problem you can blaze through and like basically hit with no problem. And also developers are so used to slow build tools and slow like development server startups that like 100, 200, 300 milliseconds, it feels like nothing. So the problem is performance is not visible and developers are really out of touch with users for performance. um, uh, like even for like performance experts who like think about performance every day, um, they're also not super in tune with like the actual product's performance. Like maybe they go to Datadog and they see the metrics and they're like, okay, how can I improve this today? Or they see a regression in performance after a specific Git commit. Um, but then it's like, okay, what do I do? Like, how do I reproduce this? It's kind of hard to do those things. Um, ReactScan is our attempt to try to fix some of this, right? Like how do we make performance visible? Like how can we show developers that there's problems on the site without like having them loaded up on a Moto G4 or something?
Moto G4, by the way, for those of you who are too young to know, is an old Motorola phone that Google still uses virtually for simulating performance of websites on low-end devices.
Yeah.
If you're using Lighthouse, that's what they use there. Um, okay, then. So you want to visualize the performance issues. How do you go about it? What do you actually show? How do I see that I have a performance issue in my React website? By the way, the tool is for React, right? It's not, for websites that aren't React based, correct?
Yeah, React for now. Um, right now we highlight renders, and if there is some sort of long task or FPS drop or INP that's really high, we turn the color of the renders to like from purple to like red or something. In the future, we wanted to have more visualizations. Like when I click a button, what is the INP or like the local tested INP? We have like or like what is the like long animation frame? Like when a long animation frame happens, I want to see that the long animation frame happened. I want to understand like when jank happens, or when jank happens, what is the cause of that jank. Renders is like our base abstraction, basically. Like usually it's always related to, it's like always somewhere within the problem, and so we show it via renders, basically.
So basically, if I understand correctly, you're adding rectangles around the React components that get rendered,
Yeah,
and these borders kind of highlight whenever the component renders. So if it's constantly highlighted, you know that this component is for some reason being constantly re-rendered, right?
exactly. Yep.
And by the way, again, re-rendering is at the virtual DOM level. So even a component might be re-rendered even if nothing actually is changed for it in the actual browser DOM, correct?
Yes, yes.
So it's your code and React code doing work for that component, whether or not anything actually gets updated in the actual display.
Yep.
And usually the border would have one color. What is it, like you said, purple or something like that?
Mhm.
But if it's causing the browser itself to actually experience delays, then it will actually change color and become red.
Exactly, yeah.
Very cool. So I assume you've tested it on various websites and saw them flashing rectangles all over the place. Can
Yeah.
you give like interesting examples?
Uh, a month ago, I found this performance problem on the GitHub site. When you would scroll on the code view, every line of code would re-render. So I tweeted it. It got a lot of likes, a lot of views. And then I don't remember their name, but someone from VP of Dev role at GitHub was like, "Hey," one day later, I was like, "Hey, we fixed this issue." And when I tested it, the FPS increased, and I was like, "Holy crap!" Like, it was really cool how just this random package we made, and then just tweeting it out and just showing a video of it actually made a real performance change on the site. Yeah,
Yeah, that's really cool. And my experience is that it's exactly that, that it's very difficult to notice that the problems exist, especially like you said, when developers have really high-end Macs and stuff like that. But once you understand where the problem is,
Mhm.
in a lot of cases, not all cases, but in a lot of cases, the fix is fairly straightforward. You've
Yep.
got, let's say, some use effect that's updating a state, which is re-triggering the use effect, which is again updating the state and over and over and over again in this kind of an infinite rendering loop, something along these lines.
Yeah, yeah. The main hard part of performance isn't the solution. The solution space is actually really small. It's usually like 1 to 5 solutions for every problem. But finding the problem is the hard part. It's almost 99% of the work.
Yeah, I totally agree with that. By the way, there are a whole bunch of sirens in the background, so I apologize for being a bit distracted. Um, Yeah, that totally matches my own experience. That it's sometimes that being able to pinpoint the cause of a performance issue is the hardest problem. But you know what? In that regard, it's not that different from a lot of bugs. The famous Heisenberg bugs that happen
Yes.
occasionally are very difficult to reproduce and figure out. And then you smack your head when you realize what the problem is because the fix is often very very straightforward. um, my question then is, how were you able to get this information out of React? I mean, React doesn't exactly tell you that, hey, you've got a performance issue. It just does this whole re-rendering thing kind of automatically behind your back. So how did you figure this out?
Yeah, most simply, so React DevTools has information about componentry and renders. Well, how does it do this? Well, React internally it attaches like a property on the window object called React DevTools global hook, and it has a bunch of information about the fiber tree. And so ReactScan internally uses that to get information about fibers. Uh, just for context, a fiber is basically like the virtual DOM, how React internally represents the user interface. We can use the fibers to detect renders, and then we show those renders using a canvas on the screen.
So you're using you're not modifying the CSS, you're actually using Canvas in order to draw the stuff on the screen?
Yes, if we modified the CSS, there would be like some overhead on that. And so any performance score you would see is going to be noticeably, like it's going to be artificially inflated. So what we did was we put the canvas on a worker thread so it doesn't have as much performance impact as if you actually modified the CSS.
Ah, cool. So what you're saying is you kind of put an invisible canvas on top of the entire rendered screen, I guess,
Yeah,
and canvas can be updated from a worker thread off of the main thread, which is not something you can do with the regular browser DOM. So you're able to I draw into this wholly separate user interface GPU layer
yeah.
without impacting the rendering time of the actual uh, browser at all. That's very, very cool.
There's a little bit of overhead because we have to still send the data over to the worker thread, but from our testing, it's pretty minimal and doesn't affect like the standard metrics as much.
I understand. Um, but for example, you still need to, for example, get the actual rectangles on the display of the DOM elements, and if they're scrolled, you kind of need to move the rectangle along with them, or something, or things along that line.
Yeah,
Correct?
exactly.
So that does still take a little bit of overhead in terms of work on the main thread, but basically you're just throwing that over into that worker, and it does the heavy lifting.
Exactly. Yeah.
Have you measured the impact, the performance impact that having React Scan on the site actually has? Because that's indeed a real problem. That it's kind of like quantum physics, where you're measuring things can actually impact the behavior of the application. Like I recently saw a tweet about somebody saying that he had a bug in his code. He added a log, the bug went away. He removed the log, the bug came back. So sometimes even the act of measuring can really impact the performance and behavior of an application. So how did you
Yeah.
actually verify that you have hardly any impact on the runtime of the application itself?
Measuring here, like, it's like not really a good way to figure out the overhead. Like, basically, we run on dev, which means it's using development builds, which is not the same as a production build. So development builds will likely be slower than production builds. Um, on a basic app, it's like less than 1%. On a
Mm.
more heavy app, it's still less than 1%. But like in reality, you have to like measure on like a large scale of applications and actually on the correct build of the app to understand the overhead. Right now, it doesn't matter too much, but like as I said, like maybe for some edge case, it might be much more.
Um, Question. As you said, you're using the same APIs that React DevTools uses internally. In fact, by the way, undocumented APIs, as
Yeah.
I understand. What is the advantage then of using React Scan over just using React's own developer tools for essentially the same purpose? Because they also have a performance view in there. If
Mhm.
you install the Chrome extension for the React developer tools, for example, you get a performance tab, a React performance tab in the developer tools. So what's the advantage of using a React Scan over that
Mhm.
capability that React provides themselves out of the box?
Yeah, like I view React DevTools as like the end game of DevTools. Like it's a great version. There's obviously improvements that can be made, but it's like the best React DevTools we have today, right? The problem is like you need kind of like a there's a like a very low like you have to be decently skilled at using React DevTools or Chrome DevTools in order to use those DevTools. And most people don't really know how to do it. Um, ReactScan is a more accessible version of it, specifically for rendering and performance issues inside your React app. React DevTools is more general, more advanced DevTools for interacting with your app. Uh, yeah, I
Do
use
I?
both.
Ah.
So I use React Scan and React DevTools for my use case.
Oh, okay, cool. So when I use React Scan, does it even require the dev tools to be open, or do I just see everything on the browser's display itself?
In development, you just drop a script tag into your like head tags, and then it should work.
And you don't need to open dev tools at all.
No, yeah, you just have it. It just runs.
You know where that's potentially a very significant advantage on mobile devices.
Mm,
The fact that I can just drop in a script tag and see the issues on the browser screen itself is a big advantage in terms of identifying such issues versus having to attach a physical phone via physical wire to a Mac or PC in
yeah,
order to open a remote debugger and then debug everything that way. It's a much more convoluted process. If I can just see all the problems directly on my mobile screen, that's a huge advantage from my perspective.
yeah, that seems like a really good use case.
Now, do you only show the squares or with the colors, or do you show additional information there?
So we do show some additional information on the screen itself. So each rectangle will have a little label on it showing the component name and also how many times it renders and how much time it took. You can also there's like a in-browser toolbar. You can inspect any component or render to see when it renders. You can replay them. You can see what props changed, what state changed, what context changed, and you can just figure out exactly what are the props or attributes or information about the React component that are causing the problematic performance.
Wow, that's really, really cool. Um, by the way, when I drop in that script tag, does it uh, automatically enable this UI, or do I also need to do something in the browser itself to enable it? Because I'm thinking that in some cases people will want to have that script tag be present, always, but not have all the users seeing those rectangles.
But yeah, by default, it only runs in development. We do offer like programmatic off and on APIs. So like companies like Notion or Shopify, what they do is Shopify, Notion, they have an internal toolbar, and basically you can click like turn React Scan on, and it opens the React Scan overlay and toolbar.
What you might want to do as well is maybe add the support for a special URL parameter
Mm,
so that you could turn it on or off using a URL parameter that doesn't hopefully doesn't conflict with anybody's URL parameter, but that would make it especially easy, especially on mobile. I'm thinking that that would be very useful. We did similar things at Wix where we added special debugging capabilities into Wix websites, but they were only enabled with a very specialized, well, not document, not externally documented URL parameter. Obviously, nothing that could actually break a website. You need to be careful because there are potential security issues around that. You
mhm,
know, somebody could send a link with that URL parameter to somebody, and then they would see the red lines, and then they would get all freaked out because they would think something is wrong or something along these lines.
mhm.
But in general, I think that this can be a useful feature.
Yeah, that's awesome. We'll add it right after this podcast.
I'm glad that I can help make the product better. Um, I also saw various demos that you were showing about all sorts of ways to graph the component hierarchies in in uh, in the React application. Is that also part of the same thing?
We haven't shipped that, but we're just playing around with what visualizations would work. So, like for context, I was working in this really large enterprise e-commerce app, and they had a bunch of components depending on the same context, but it was really convoluted, right? Because there were like nested hooks, there was nested components, like a bunch of stuff was re-rendering, and I didn't know why. So I spent like 10 hours just on TL Draw graphing out the entire code base from the route that was re-rendering. And I was like, why the heck am I doing this? Like this is like so much work just to figure out why all these components are re-rendering. One thing we want to try is doing this automatically. Like, can we graph out the component tree and also the hooks tree, and show where the source of the problem is? Most like re-rendering issues, like they can be caused by a higher component or a context, but usually they're systemic, right? Like it's usually like one context causing all of these components to re-render, and all of these components have faulty implementations that cause this performance issue. Um, so we're trying some visualizations to help fix that.
So we have a user from LinkedIn who asked, what is the business model for the ReactScan project? Is there a cost to using ReactScan? I'll fill in the blank. Is it open source? Is it free? What's your business model around this tool?
Yeah,
Are
so
you? Is it already released? Is it beta? Where are we at?
yeah, it's not 1.0, but it's stable. You can try in your app. It's free, open source. You can copy the code, you can fork it, you can do anything with it. If your company requires it to be hosted on our internal package, you can do whatever you want. The way we make money is through monitoring and observability. So we have a different product that uses React Scan on like ETE or staging environments. So you can run your playwright test. We figured out the performance scores of those playwright tests and tell you whether the performance increased or decreased. This is a
Hmm.
real problem because like most observability tools like Sentry, Datadog, they're really confusing, right? You have to like read profiles. The graphs are somewhat like weird, like and it doesn't really tell me like what is the root cause of the problem. We're trying to solve this. We're trying to do this solve this for React.
So it's essentially a performance budget tool for React applications.
Yeah, exactly.
By the way, for again, performance budget is something that we mentioned in previous episodes. For those of you who don't remember or don't know what it is, a performance budget is a way to say, like, specify how performant I expect my application to be, and then during the testing process in your CI/CD flow, you can measure the performance of the latest build, compare it to your budget limits, and if you exceed your budget limits, you essentially break the build like you would for any other bug. And then the only way in which you can release it is either fix the performance issue that you're under budget again, or unfortunately in some cases you might need to increase the budget because maybe you just made the UI more complicated and sophisticated, and therefore it's a legitimate decision to make, but you're doing it uh, with full awareness of what you're changing. It's not just something that happens and you're not even aware that it's going on, that your application is becoming slower.
Yeah.
So you're building a performance budgeting tool that's focused on React application. It's not just working at the core web vitals level. It's focused on React, and it helps you understand how your React application is actually working in terms of performance. And if you exceed your budget, not only does it break your build, but it also tells you where the problem is likely at.
We do also do core vitals. So basically, the uh, data hierarchy is interactions. So if interaction becomes slower on your playwright test, that's a problem. Then we go a little bit deeper out. Like if an interaction is slow, what components may have caused that, or what components under where may have caused that, and then potentially like down to the render, like what props, context, or state may have changed.
Now, what I'm thinking that might be really useful in this context is something, although off the top, I'm not exactly, it's more of a vague idea that I
Yeah.
have rather than a plan. But, one way in which React performance is improved in at least in perceived performance, if not actual performance, is using suspense
Hmm.
by deferring rendering of certain non-urgent UI components. Maybe they're outside the visual
Yep.
display area, or maybe they show lower important information or stuff like that. How how do you handle those? Can you recommend to me that this thing should use suspense or stuff like that? Is that something that you're thinking about or looking at?
Yeah, of course. That's all in scope, basically.
Cool. And so any like hints about what you're thinking about doing in this context?
Specifically so there's a couple applications like um, things outside the viewport. If it renders, we mark that as like an unnecessary render. Uh,
Hmm.
like there, I mean, like obviously there are different solutions here. Like first, maybe don't render it, or maybe there are some like hacky solutions for like partial hydration, like don't hydrate unless it's viewed, uh, or like suspense, as you're saying. Um, we don't do recommendations yet, but we do detect the problems itself right now.
Okay, so when you're doing when you're doing that rectangle highlight, if the rectangle is wholly outside uh, the visual the visual viewport, then it gets kind of flagged and logged that, hey,
Yeah,
this was an unnecessary render. You should be doing something about avoiding that,
exactly. Yeah.
or postponing that, or something along these lines.
Mhm.
That's very, very nice. So you said that you're using both React Scan together with with the React Dev Tools. What, where do you focus? What information do you get where? Like,
Yeah.
what's the benefit of
Mhm.
using them both together?
Yeah, anywhere from like skill level 0 to skill level maybe 70 or 80%, which is basically like looking in the renders where they occur, inspecting components with props change or components change. I use React Scan for. For React DevTools, I use the profiler component. So like it shows like a timeline of like what functions ran. I also use the Chrome DevTools profiler. And then sometimes I use the component tree provided within React DevTools. Like obviously, if React DevTools works for you, you should use it. I recommend giving ReactScan a try. If it works better for certain use cases, you should use it for use case. If it doesn't, then don't.
One more thing that you might try to do, assuming it's not too complicated or doesn't have too high overhead in and of itself, is that if the user hovers on top of one of those tooltips, then that you render on the canvas, then you could display additional information like what caused the latest render or stuff like that, things that wouldn't fit inside the tooltip in its own of itself. Again, anything that can save me the need to have to open Chrome DevTools and go back in history would be very beneficial. Obviously, a problem with hovering is that it doesn't actually work on mobile devices. So maybe a click on those,
Yeah,
tapping on the tooltip or something along these lines. That could be useful again, especially because on mobile devices, accessing DevTools becomes a lot more challenging. So anything you can show on the mobile display itself is very beneficial.
that's an amazing idea. Yeah, this is
uh,
perfect. I'm just getting. This is like a user interview. Product ideas.
well, performance is my jam. So, I've been doing this for a long time. Long, I wouldn't say longer than you've been alive, but starting to come on that. So, yeah. Anything else you want to tell us about your tools or things that you're looking at doing or things that you want our listeners to know about?
Yeah, I mean, if there's one thing you should do is performance matters a lot, like probably more than you expect. And even if I mean, like even if it doesn't matter at your company, like people leadership doesn't really care, you should try at least see if it maybe will improve some metric for users or improve your sales. If you're just an individual user, try learning how performance works, upskill yourself. Performance, like from my experience, um, there are not that many performance experts, and there's a lot of need for performance experts. And so, from a job opportunity perspective, there's also there's an opportunity there. So learn performance, try ReactScan if you want to, and yeah.
In this context, by the way, there's the excellent web.dev website, which is
Yes.
actually run by the Google Chrome DevRel team, I think. And they have a section there called case studies, case-studies on web.dev, which basically is just this huge list of case studies of companies that improved their performance and got a huge boost to their sales or bottom line or whatever as a result. So if your company doesn't care about performance and you need to convince management that performance is actually important, then web.dev slash case dash studies is a great resource to use in this context. And I totally agree with you that having good performance is a game changer in many cases. It's the whole difference between an application that's pleasant to use, that's engaging, versus one that you hate using because it's janky and unresponsive.
For sure. Yeah.
And it's also an accessibility thing. Um, and it's about enabling people who might otherwise not be able to use your application to actually use it and benefit from it. Because again, like you said, if your application was written by people with really high-end devices, fast Macs, fast iPhones, and they never bother to check on lower-end devices, or they just don't care about performance because it's good enough on their own devices, they not may not be aware that people on lower-end devices just find their application wholly unusable.
Yeah, exactly. And you'd be surprised the amount of e-commerce companies where performance actually matters to sales that don't monitor performance or care that much. And so what happens is they are literally losing out on like 7 to 8 figures sales every year.
By the way, again, speaking about React, we had Rick Vixcomi from Google on our show a few years back, and he runs this great service. I don't know if you're familiar with it. It's Chrome User Experience Report, or CRUX.
Yes.
And they have this website where you can actually see the performance graphs by technology. So Google literally grabs performance information from your browser, unless you opt out from your Chrome browser, and they upload it into their database anonymously, of course, or at least so they say. And then they run all sorts of analyses on it, including which technologies it uses. And that makes it possible, for example, to see how good React websites in general are in terms of performance. So we mentioned the three core web vitals. A site is considered to have good performance if it's good for all three core web vitals. That means that it's fast enough at the 75th percentile for LCP, for CLS, and for INP. For example, LCP needs to be faster than 2.5 seconds at the 75th percentile, as I recall.
Yep.
And it turns out that if you look at React websites, can you guess what percentage of React websites in the totality of all React websites actually get good core web vitals?
Uh, if I were to guess, maybe like 10 to 20%.
No, you're being overly harsh. Uh, it turns out, well, it used to be that way, but it turns out that the browser makers have been doing a phenomenal job of improving the performance of the platform itself. So even though React websites in and of themselves may not have improved that much, just because the browsers have been getting better and faster and more sophisticated, then the React scores have gone up. In fact, all website scores have gone up.
Amazing.
So so if I look, so we were at 20% on React websites back in 2021. So in April 2021, we crossed the 20% threshold. Now, React websites are 41% have good core web vitals.
That's phenomenal.
So
Yeah.
that means that almost, well, 59% don't, which is the majority of React websites, which is truly unfortunate. By the way, if we compare to other technologies, WordPress is slightly ahead of React. So people building WordPress websites, uh, they are at 43%. So they are 2% better than React. So you're thinking you're a hotshot React developer, and I'm talking to our listeners. There's a good chance that the WordPress website built by some web designer has better performance than your sophisticated React website. And if I'm looking at other technologies, like you mentioned, Shopify is at 76%. And Wix, for example, is at 65%. So 76% of all the Shopify websites have good core web vitals, and that's almost double React. That's pretty unfortunate from my perspective.
Yeah.
And
No comment.
hopefully with tools like ReactScan, people can make their React websites more like load faster, be more responsive, and generally be more pleasant and more accessible to use. By the way, have you also thought about doing things related to accessibility in your application, or are you for now focusing wholly on performance?
For now on performance, but that'd be a cool extension if there is enough of a need for that.
Mm, I think there should be, but it's your business. So if people want to try out React Scan, like you said, it's open source, it's free to use, how can they go about it? And if they want to try out your more sophisticated tools for the CI/CD pipeline, how should they go about it?
Yeah, you can just go to reactscan.com. That's react-scan.com, or just look up React Scan on Google. There's resources. It tells you how to install the basic React Scan, and we have another page called monitoring, which should be on the website that you can click on and then try to demo and then add to your website yourself. React Scan takes less than a minute to set up. Our monitoring service takes also probably less than 5 minutes.
Is it also possible to add it to a page using npm, or is it just via script tag?
npm script tag, you can run it via your CLI. There's like 4 ways to do it.
Cool. Anything else that you want to mention or talk about in this context?
Not at all. I just really grateful to be on this podcast, and good to talk to you again, Dan.
Yeah, same here. I love talking about performance, and I love seeing somebody so young, so into it, and making such an impact in this context. Bringing anything we can do to improve the situation with React um, is great in my book. I mean, at the very least, we need to be above 50%. I mean, at the very least, more than half the React websites should have good performance. By the way, what is also surprising to me and even more unfortunate, can you guess what the situation is with Next.js?
Is it lower than React?
Surprisingly, it is. You would expect it to be higher because it provides SSR and SSG, which are great for LCP. But it isn't. I actually have a talk that I gave on this topic, trying to kind of analyze why that is. But the bottom line is that, as I said, with React, it's 41% of React websites, or websites using React would be a better way of phrasing it, have good core vitals. With Next.js, it's only 28%.
Yeah, I'd be curious why. That's interesting.
Yeah, I'd be curious why as well. I'm guessing part of it is maybe having to do with the long tail. of old Next.js versions, maybe not installed on Vercel, maybe installed on AWS and not properly optimized. But it's a good question of why that is. And like I said, I have several theories, and I've even given talks on this topic. So if you're running a conference and you want to hear my opinion about why some frameworks are faster than others, then invite me to speak at your conference. um, Anyway, um, okay, I think with that, I'll be pushing us to that final part of our episode, which is the picks part. I didn't give you a heads up for it, or I hope that you came prepared nonetheless. I'll go first, so you'll have time to choose.
Okay.
Basically, picks is where we shout out whatever. It can be technical things, it can be non technical things, it can be your favorite movie, TV show, band, whatever, book. Do you still read books? um, and or technical things that you want to just shout out about, including your own. So I'll start with mine. I don't have a lot in the way of picks. I have just the one. Um, so I'm from Israel, from Tel Aviv in Israel. Obviously, the situation here has been really unfortunate over the past year, with over a year, almost a year and a half, with the war going on and a lot of suffering and loss of life. At least we got some really great news as yesterday, as of the time of this recording, where a ceasefire has gone into effect. And in particular, three Israeli hostages were released. They were held in captivity by Hamas for 471 days. Just imagine being held in a tunnel underground with the threat of death constantly hovering over your head, with hardly any food and no ability to move, and some of them were also victims of abuse, even sexual abuse. It's very distressing. So three of the hostages were released yesterday as part of this agreement between Israel and Hamas. Their names are Doron Steinbacher, um, Emily Damari, and I should have come better prepared, and Romi Gonen. Two of them were actually abducted from their own homes. So on October 7th, 2023, uh, Hamas terrorists broke into their home, kidnapped them literally out of their beds. One of them was shot. She lost some fingers in her hand, and they were taken into Gaza and literally in their pajamas. The third one was kidnapped from the Nova Music Festival. Again, she was also shot and wounded, and they never got medical attention for that. And I'm really happy that they've been finally been released and reunited with their families. Hopefully, they'll be able to make a full recovery from this ordeal. Obviously, it's not simple, but and that still leaves 94 hostages, Israeli hostages, in Hamas's hands. I really hope that the ceasefire can persist, and these hostages will be released eventually as well. Hopefully as soon as possible. And that would be my pick for today. It really brought joy to my heart yesterday when these hostages were finally released. And that's my pick for today. Do you have any picks for us, Aiden?
Uh, I have one pick. I have much less important, but
Yeah.
uh, I mean, I knew this since a while ago, but I really like the proxy API in JavaScript. So basically, you can wrap any object in this like proxy keyword, and then you can spy on any property. So if you access like object.name, you know when that you can like programmatically know when that property is accessed.
Oh yeah, proxy is really cool. Yeah, basically you do a new proxy and you pass in the object you want to, um, what would be the instrument or track, And like you said, any access to either read a property from that object, write a property to that object can be tracked, can also be modified, by the way.
Yeah.
So you can kind of it the one thing to be careful with, by the way, in this context is that it can be used, and it was in fact created for that purpose, to kind of break JavaScript semantics in a
Yes.
sense, because you can override the standard JavaScript object behavior with proxy. I've actually done exactly what you described. I had a problem in an application,
Mhm.
a legacy application that I was trying to refactor. Some code was modifying a global object, and I was unable to locate where that modification was happening. So I literally created a proxy around that global and put a debugger statement in the property set, and that way I when the break happened in the developer tools, I had the call stack and I could find where that operation actually happened. That was I felt like having a superpower when I
Yeah.
was able to do that. Um, yeah, proxies are very powerful. By the way, another use of proxies, I don't know if you know this, but Vue, I think, uses proxies, at least in the development mode, to implement their reactivity.
Yeah. I think Valtio and some other state management too. Or you can use it to like for if you want to get fired, you can use it to prank your coworkers.
Okay, now you have to tell me, what did you do?
I haven't done it, but I was thinking of replacing like we have an internal library, like returning a proxy and having all the properties return undefined or something. But yeah, something super stupid.
Yeah. Okay. Well, boys will be boys or devs will be devs, I guess. Yeah. Anyway, Aiden, it's been really fun having you on the show. I'm really excited about the stuff that you're doing. I'm really happy whenever something comes along which makes it possible to improve performance on the web. We definitely need more of that. And it's amazing to see somebody so young making such an impact. And I hope to be hearing more great things from you and having you on the show again to talk about more stuff that you're doing.
Yeah.
Now,
Thanks for chatting.
if people want to contact you about, your existing projects, more ideas for what can be done and improved with these, or maybe ideas for future projects, what's the best way to reach out to you?
I'm on Twitter, Blue Sky, YouTube. Just look up my name, and then you can just DM me, and I'll answer you.
So it's Aiden Bai on all those platforms.
Aiden Bai. Yeah.
Aiden Y Bai. Okay, great. So again, Aiden, thank you for coming on our show, and to all our listeners, thank you for joining us. And that's it for today. Bye.